So friends, we'll see average acceleration in this, and obviously I'm Hitesh Sharma, your host and a ghost. Okay, so let's start. Acceleration is basically the rate of change in velocity. Okay, rate of change in velocity is acceleration. So average acceleration is change in velocity upon the time it takes. Okay, change in velocity will be meter per second, that is meter per second square. Okay, so if the average acceleration or acceleration is 10 meter per second square, we can say the velocity changes by 10 meter per second every second. Okay, this is how we should look at acceleration. By mathematical definition, change in velocity over time taken, v final minus v initial by delta t. Obviously, if you'll talk about direction of acceleration, average acceleration is parallel to v final minus v initial vector. Okay, so average direction, acceleration average has a direction parallel to v final minus v initial, और change in velocity की डायरेक्शन में ही एवरेज एक्सेलरेशन की डायरेक्शन होती है. ओके, लेट्स स्टार्ट विद द फर्स्ट क्वेश्चन. पार्टिकल मूव्स कांस्टेंट स्पीड u, टर्न्स बाय 90 डिग्री इन टाइम t, फाइंड द एवरेज एक्सेलरेशन ऑफ द पार्टिकल. ओके, मान लेते हैं पार्टिकल ऐसे जा रहा था, ऐसे, और इधर टर्न ले लिया उसने 90 डिग्री से. ठीक है, सो दिस इज योर इनिशियल वेलोसिटी एंड दिस इज योर फाइनल वेलोसिटी. v फाइनल का मैग्नीट्यूड u है और इनिशियल का भी मैग्नीट्यूड u ही है, एंड दिस इज दिस. सो व्हाट इज चेंज? v final minus u, so final minus initial, delta v is final minus initial. So this is final and this is initial. With a minus sign, just reverse the arrows. This is minus v initial, this is v final. So the resultant will be root 2 u. Again v final और minus v initial का resultant चाहिए हमें. So this will be root 2, which is the magnitude of v final minus v initial. Okay, so change in velocity is root 2 u and time taken is t. So average acceleration is simply root 2 u by t, and the direction is this. Okay, in the next question, there is a particle moves on a circular arc of radius r, covers an angle theta with constant speed u. Find the average acceleration. Let's draw the diagram. Let's say particle moves in this circular arc which makes an angle theta at the center. So obviously the distance covered will be r theta. Theta is in radians. This is the initial velocity and this is the final velocity. Magnitude is same u. So first of all, time is distance upon speed, so that is simply r theta by u. And what is change in velocity? The change in velocity is not zero. Change in velocity is final velocity. This is final, this is final, minus initial velocity, and this is initial. Okay, so just take the vectors, sum of this. This is v, this is initial velocity, this is final velocity. Final minus initial by reversing its direction, and the angle between these two vectors is nothing but you can say the angle between these two vectors will be theta, so it will be pi minus theta. Both have magnitude u, so it will be 2u sine of theta by 2. So the change in velocity is this, and average acceleration is delta v by delta t. So we get 2u sine theta by 2 over r theta by u. Just solving we can easily find out. It will be u square by r sin theta by 2 over theta by 2. Okay, ये 2 नीचे आ गया, u ऊपर चला गया, so it will be u square by r sin theta by 2 over theta by 2 is the average acceleration, and the direction will be along the bisector towards the center. Okay, so this is the average acceleration. In the next part, a particle strikes the ground with 10 meter per second and rebound with 6 meter per second in 4 milliseconds. Find the average acceleration. Initial velocity is 10 downwards and final velocity is 6 upward, and time interval. First of all, calculate delta V, which is V minus U. 6 minus 10. Why minus 10? Because it is downward, or we can say it has changed its direction, so obviously change will be 16 meter per second, and time taken is 4 millisecond, so that is 4 into 10 raised to power minus 3, so acceleration will be 4 into 10 raised to power 3 meter per second square. That is a huge acceleration. Okay, that is a huge acceleration. So whenever bodies strikes, the acceleration is very high because change in momentum takes place in a very short interval of time. That's why the force is very high. If a ball hits your face, then you will be able to realize that force or that huge acceleration provided by your face to the ball. Okay, I'm just kidding. Enjoy.